Welcome to Learn Yourself. Today we are going to study about chapter hydrogen. This chapter is under ICSE Standard 8 syllabus. So let us start our chapter with a scientist who have given their contribution in discovery of hydrogen. So there are three main scientists, Robert Boyle, Henry Cavendish and Anthony Lavoisier, who have given their contribution to discover hydrogen, and they established hydrogen as an element, and they also discovered that hydrogen is one of the key element in a manufacturing of water. You can synthesize water in the laboratory, that also they have discovered. So Robert Boyle was the first scientist who established elementary character of hydrogen. That means he said that hydrogen is an element. Henry Cavendish was the second scientist who said that hydrogen can burn in air and it will produce water. While hydrogen will burn in air, it will burn with the help of oxygen. And when it is combining with the oxygen, hydrogen will combine with oxygen and it will synthesize water. Then Anthony Lavoisier said that hydrogen is an element who is a water producer. That means he synthesized water in the laboratory. So these are the three main scientists who said that hydrogen is an element and hydrogen is a water producing element. Now, how can we prepare hydrogen? Before going to the preparation of hydrogen, we need to understand this activity series of metal. Now, what is the activity series of metal? Activity series of metal will tell us that what all metal are active, which metal is active compared to which metal. That means what all metals you can see at the top, they are active. As you are going from bottom to top, the activity or reactivity of the metal will increase, and as you are going from top to bottom, the activity or reactivity of metal will decrease. That means potassium is the most reactive element, most active element, whereas Au means gold is a least reactive or active element. Now, one important feature of this activity series is the metal which is placed above the metal can replace the below one. That means if in the reaction the aluminium is there, then magnesium, being a more reactive compared to aluminium, it can replace aluminium and take the place of aluminium. This we will discuss more in 9th standard with displacement reaction. Here you need to understand only that this is the activity series, and you have to remember that what all metals are active. Here all the metals placed above hydrogen are termed as active metals. All these metals are termed as active metals. So whenever I will say, or your textbook or curriculum say that this active metals reaction, that means any of this metal can react in that reaction. So these are the active metals, and the metal which is placed above the metal can replace the below metal in the reaction. Now we will see that in this one of the reaction. Now these are the preparation of hydrogen. First, with the cold water. You can prepare hydrogen or you can synthesize hydrogen with cold water when it reacts with potassium. We know that potassium is a very active element. So when it reacts with cold water, it will give us metal hydroxide and hydrogen gas will evolve from that. So potassium will give us potassium hydroxide and it will give us hydrogen gas. Now from steam also we will get hydrogen, that when magnesium will react with water. Now you can see, if it was when it was a potassium, being a most reactive element, it was reacting with cold water also. But now as we are going down, we are using magnesium, and magnesium is less reactive compared to potassium. So to perform a reaction and to get the products, we need a more heat compared to cold water. So we are utilizing here a steam and not a cold water. If you will use a cold water with magnesium, then probably your reaction will not start. Why? Because magnesium is not as reactive as potassium, whereas potassium is very reactive, so it will react with cold water also. But magnesium is being a least reactive or less reactive compared to potassium. We need to use steam. So that heat will help magnesium to activate it and it will give us magnesium oxide. Here it will give us a metal oxide and hydrogen gas. Whenever any oxygen is reacting with metal, and whatever molecule will form is known as metal oxide. This is known as metal hydroxide. From acid. Now magnesium can react with acid. So magnesium when react with acid, it will give us magnesium chloride. So this is a salt of metal. So you can say a metallic salt will produce and hydrogen gas will evolve. Then from alkali. Now what is the meaning of alkali? When any base can dissolve in the water, that is termed as alkali. So when alkali will react with zinc. So zinc and alkali together will give us Na2ZnO2 and hydrogen gas. So this molecule's name is sodium zincate and it will give us hydrogen gas. So according to the activity series of metal, they will react with acid and water and it will evolve hydrogen gas. Now earlier we have discussed that a metal which is more reactive can displace a less reactive metal. So we are taking here an example of magnesium and hydrogen. Here magnesium is more reactive compared to hydrogen. So why we have taken here hydrogen and that too in the bracket, even though the hydrogen is gas, but it is very reactive and hydrogen can react with metal, we have placed in the activity series in between the metal. And we are also treating hydrogen as a prime active element. So magnesium is more reactive compared to hydrogen. So here this displacement reaction can possible, in which magnesium can displace hydrogen from HCl and it will form MgCl2. If you have taken here silver at the place of magnesium, then this reaction would not have possible because silver is less reactive compared to hydrogen and it cannot replace hydrogen from this HCl. But here we have taken magnesium which is more reactive compared to hydrogen. So that's why it has replaced hydrogen from this molecule and it has become magnesium chloride. This salt can be possible only if any of this metal is there. If any metal below hydrogen is there, that means this reaction cannot be possible. This topic is new as we are discussing here an electrolytic cell, that how the cell will work and what all components are important in this electrolytic cell. First of all, we will see that what all things we require for this electrolytic cell. So distilled water we have taken into this and then we will acidify this. Why? Because the distilled water cannot conduct electricity. Because in the distilled water there are not much amount of ions or minerals which can conduct electricity. So when we will add a few drops of sulfuric acid, then this acid will dissociate water into H plus and OH minus ions. This ion will help in the passage of electricity. This ion will work as a carrier of electricity. So it is important that when we are using a distilled water as an electrolytic solution or in the electrolysis cell, then we have to acidify it. Then only the current will pass because distilled water cannot conduct electricity. Now acidification help in the dissociation of ion, that is H plus and OH minus. To conduct the electricity, we need iron. Now, in this electrolytic cell, there are two main important terms. First is electrolyte or electrolytic solution, and second is electrodes. First we will see electrolyte. Now what is electrolyte? A chemical compound which conduct electric current, undergo chemical decomposition due to flow of current. For example, here we have taken as an electrolyte water. So water will decompose into H plus and OH minus. So electrolyte is a chemical compound, any chemical compound which can dissociate and which will conduct electricity, you can take as an electrolyte. So this chemical compound, what it will do? When it will dissociate, and it has to be in molten state or in a liquid state, then only the flow of ion, and then only it will dissociate, and then only the flow of ion can be possible. So once they will dissociate, they will give us ion, which are responsible for the passage of electricity. Now electrodes. What are the electrodes? There are two electrodes. One is anode and other one is cathode. Now here, if you will see, this is an electrolytic cell. In this is anode and this is cathode. Why? Because I have attached this and to the battery to the positive terminal. That's why it has become anode. Electrode are neutral. Electrode can never be positive or negative. It is depending upon the which terminal you are attaching to the positive terminal of the battery and which terminal you are attaching with the negative terminal of battery. So here, when this is a battery and this is a positive terminal of a battery, when this positive terminal I am attaching here, that means this will become my positive electrode, and that is anode. If this I have attached here, then this would have become my positive terminal. But since I have attached this positive terminal of battery to this electrode, this has become positive electrode, and that is anode. Always in the electrolytic cell, anode is a positive electrode and cathode is a negative electrode. So here the negative terminal I have attached to this electrode, so that's why it has become cathode. So this is negative electrode and that is cathode. Now here this electrode, both the electrodes are of platinum. I have put a strip of platinum into this electrodes. So they both are same. Since I have attached this with positive, this has become positive. This with negative terminal battery, this became negative terminal. So these two are platinum electrodes, and in this is a distilled water, acidified distilled water. So once I will start the current, once I will switch on the battery, then the current will start passing. Then current enters the electrolyte through anode. So from here the current will enter into the electrolyte. Electrolyte is our solution, and it will pass through this electrolytic solution with the help of these ions, and it will leave the electrode from the cathode side. So it is a continuous circulation of electricity from the anode to cathode, and with the help of these ions. Now electrolysis. Now this is a process. These two were important component of electrolytic cell. This is a process, that is electrolysis. What is electrolysis? It is a process of decomposition of chemical compound. So which compound here has been decomposed? Water, resulting into ions. So it will decompose and it will give us ions. And the third one is discharge as neutral atom at their respective electrodes. So now when we will get the hydrogen and oxygen, this both the things at anode and cathode, then the anode as being positive electrode, the oxygen will attracted towards anode. So at the anode electrode we are collecting oxygen, because oxygens oxygen is negative element, whereas cathode is negative electrode and hydrogen element is a positive and it will attracted towards cathode electrode. So hydrogen gas we are collecting at the cathode terminal, oxygen gas at anode terminal and hydrogen gas at cathode terminal. So here if you will see, when we will get 1 volume of oxygen, we will get 2 volume of hydrogen gas. Now why is it so? Because from 1 molecule of H2O we will get 2 atoms of hydrogen and 1 atom of oxygen. So whereas as and when the 1 molecule of water will decompose, you will get 2 atom of hydrogen and 1 atom of oxygen. That's why the oxygen amount will be half compared to hydrogen's amount. So when this process will get over, you will get 2 volume of hydrogen and 1 volume of oxygen. That is because the ratio of the water molecule. The ratio of water molecule says that atoms are in a combination of, that's why what all hydrogen gas you will collect half of that volume for the oxygen gas. That is because of the ratio of water molecule. That's why you will get 2 volumes of hydrogen gas here, whereas 1 volume of oxygen gas at the anode terminal. So here in our syllabus there are 2 types of preparation of hydrogen gas is there. So this is a first method, that is laboratory method. The second method is according to Bosch process. So here we are studying that how we are arranging the apparatus, what are the precautions we have to take, what reaction will be there and which will give us a correct amount of yield of hydrogen, and if we are following certain criteria, then what are the reason behind this. So let us start with our apparatus setting. Here this is a round bottom flask. I have arranged 2 pipe into this. From that, one is a thistle funnel. Thistle funnel is a pipe and on top of the pipe there will be a bulb. So in that you can add some liquid. So this thistle funnel will allow that liquid to add into this medium in a dropwise manner. So whatever solution you will add in thistle funnel will add in a reaction in dropwise manner. So that is a function of thistle funnel. Along with the thistle funnel, one more gas pipe you can see it here, which is going inside. This gas pipe is the another end of the gas pipe is directly going to this assembly. This is a water bath. Into that I have placed this a gas jar. This gas jar is meant to collect the gases. Here we are collecting a hydrogen gas via downward displacement of water. That means this gas jar I have placed in a water bath. Now as the hydrogen gas will come through this gas pipe, the water will come out from this gas jar and that place will be occupied by a hydrogen gas. So that is the meaning of we are collecting the hydrogen gas via downward displacement of water. As the hydrogen gas will come here, the water will go down. Now when we are starting our process, the water will fill till here. As the gas will come, that gas will take the place of water and water will go down. So that is the meaning of we are collecting a hydrogen gas via downward displacement of water. Each and every gas we have to particularly check that how can we collect it. Some gases we can collect via downward displacement of air. Some gases we have to collect via downward displacement of water. That we will discuss it later. So in our assembly there are 2 pipes going into a round bottom flask. Now thistle funnel has to be dipped inside the dilute HCl. In round bottom flask I have also added a granules of zinc. So this zinc granules will react with dilute hydrochloric acid and in turn our product will form, that is hydrogen gas. So that hydrogen gas will go and it will travel through this gas pipe and it will go to this gas jar, and with downward displacement of water we are collecting a hydrogen gas over here. So that is how we have arranged our assembly. This is our reaction, that when zinc will react with two molecules of hydrochloric acid, it will give us ZnCl2, which will remain here, and hydrogen gas we are collecting in the gas jar. Now these are some of the points which we need to discuss, that zinc has impurities of copper 2 sulfate, which will give a catalytic effect to this reaction. When we are adding a zinc granules to this, zinc granules will have an impurity of this, that is copper 2 sulfate, and it has a catalytic effect. So this will work as a catalyst and it will make this reaction faster. So we do not want to purify the zinc granules from copper 2 sulfate because it has an advantageous effect over our reaction. So this impurity is helping us in our forward reaction. Second point is sulfuric acid can't be used. At the place of hydrochloric acid we cannot use sulfuric acid, because sulfuric acid is a strong oxidizing agent. It will further oxidize this hydrogen gas into a water molecule. So we cannot use H2SO4 at the place of hydrochloric acid. Then collection. We have to collect the hydrogen gas via downward displacement of water. Why? Because if we are collecting it via downward displacement of air, then hydrogen gas will mix with air, and air hydrogen mixture is quite explosive. So we cannot collect hydrogen gas along with the air. We have to collect it along with the water, and hydrogen gas is not soluble in the water, it is insoluble. So we can collect hydrogen gas via downward displacement of water, but we cannot collect hydrogen gas with air or via downward displacement of air, because hydrogen gas and air mixture is explosive. Then some of the precaution we need to take when we are doing this laboratory method. First is leakage. So we have to check all these points where we are connecting the two apparatus. So at this place, if the leakage will be there, then we will not get our yield properly. Second is hydrogen gas. Hydrogen gas is quite an explosive and it will burn rapidly. So while we are handling this hydrogen gas full of jar, then we need to be bit cautious. Then third is thistle funnel. The end of the thistle funnel should be dipped inside the hydrochloric acid. Otherwise what will happen, if it is here, then this hydrogen gas might come through the thistle funnel and will go out. Then we cannot collect our yield properly. So this thistle funnel should dip inside the hydrochloric acid. So the hydrogen gas will not escape through the thistle funnel, and the gas has only way to come out is that our gas tube. So thistle funnel's point should be dipped inside the hydrochloric acid solution. So this is how we can prepare a hydrogen gas via laboratory method. So in this method we need to remember this equation, then some of the important points which can be asked in reason, that why we are not eliminating this impurity, then second, why we are not collecting the hydrogen gas over air, then third, thistle funnel's end should be dipped inside the hydrochloric acid. So all these things you need to remember and you need to understand. So let us see now that how can we manufacture hydrogen gas via Bosch process. So in this process there are three steps. First, we are making the water gas. Then in second step we will get our product, and in third step we are removing the impurities from the product. In the first step we are taking white hot coke that is reacting with the steam. This reaction is happening at 1000 degrees Celsius. So we will get the mixture of carbon monoxide and hydrogen gas. This mixture is collectively known as water gas, and we need lot of energy. So this reaction, when here minus delta is there, that means this reaction is endothermic. That means we have to give energy to perform this reaction. So in first step we will get water gas. And what is a water gas? That is a mixture of carbon monoxide and hydrogen gas. Now in this step we are doing it in specially designed converter. In the second step, water gas, that is a mixture of carbon monoxide and hydrogen, again we are passing on steam, and this reaction will happening at 450 degrees Celsius with the help of one catalyst and one promoter. Our catalyst is Fe2O3, that is iron 2 oxide, and our promoter is Cr2O3. So one is catalyst, this is catalyst, and this is promoter. With the help of this two, our reaction rate will become faster and this reaction will move towards the forward direction. And we will get here carbon dioxide, some stresses of carbon monoxide, and our product, that is hydrogen gas, and lot of heat energy will be released. So in second step we will get our product, but this product is along with carbon dioxide and carbon monoxide. So in third step we will eliminate this two. How can we eliminate this two? That for carbon dioxide, how to remove carbon dioxide? Then we will dissolve this mixture in water under pressure. So what will happen, that carbon dioxide will get dissolved but hydrogen gas will not dissolve. So we will extract it. Then potassium hydroxide, this potassium hydroxide will react with, we will dissolve this mixture in potassium hydroxide. So carbon dioxide will react with potassium hydroxide and will give us potassium carbonate and H2O, and hydrogen gas will remain as it is. So these are two different methods by which we can eliminate carbon dioxide. Now for carbon monoxide, we can dissolve the mixture in ammoniacal copper chloride. So when we are dissolving this, carbon monoxide will react with it and our hydrogen gas will remain as it is. So this is how these three steps are there, that is for the purification step, and so that we will get our product in purest form. Our reaction steps are two. In first step we will get water gas, and in second step, when water gas is reacting with the steam, when water gas is passing through the steam, then it will give us carbon dioxide and hydrogen. And here we are using, so this is how we can manufacture hydrogen gas via Bosch process. In this process, the yield of hydrogen is relatively very high. So this process is also known as industrial process. Under physical properties of hydrogen, what is the meaning of physical properties? Physical properties means by seeing or by looking at it, or the physical appearance of it, or we will just check whether they are acidic or basic without performing any chemical reaction. What all properties we can check, all those properties are termed as physical properties. So here all these physical properties we are going to learn about hydrogen. That color, it is colorless. Odor, it is odorless. Physiological nature, it is non-poisonous gas. It is not harmful. Then density, hydrogen is lighter than air. Then solubility, it is very slightly and it is very sparingly soluble gas, and that's why we can collect hydrogen by downward displacement of water. This we have already learned in laboratory method of hydrogen. So it's very slightly soluble in the water. And nature, it is a neutral gas, and when we are placing a blue litmus paper on the mouth of test tube filled of hydrogen, then that blue litmus will remain blue and red litmus will remain red. So that's why it is termed as neutral gas. It won't affect the blue litmus as well as it won't affect the red litmus. So the nature of gas is neutral, and one of the important property of hydrogen is it is lighter than air. So now we are going to see two different experiments about the hydrogen is lighter than air, and we will try to prove and we will confirm that hydrogen is lighter than air. So under the physical property of hydrogen, that hydrogen is lighter than air, we are going to learn two different experiments through which we will confirm that hydrogen is lighter than air. This first setup is exactly similar to the setup of laboratory method of hydrogen. In laboratory method of hydrogen, we have learned that we have taken here zinc granules, and from thiosulfonal the drop-wise addition of hydrochloric acid is there. So when hydrochloric acid and zinc will mixed up, here we will get ZnCl2 as a product. This is our first product as a product, and the hydrogen gas will comes out, evolved, and that hydrogen gas will travel through this gas tube and it will go to this bath, and this is a soap solution. So when the hydrogen gas will travel through this gas pipe and it will come here, then through the soap solution whatever gas is evolved out through this gas tube, that bubbles will go up in the air. It suggests that hydrogen gas is lighter than air. We know this reaction, so we knew the result and we knew the products of this reaction. So we know that from this gas pipe the hydrogen gas is coming out. So why we have taken here soap solution? So that the gas will form bubble. If it will be a water, then only you can see the bubbles are coming till the surface and it will burst out. You cannot see the bubbles that is coming out and going up. We want to know that whether hydrogen gas is lighter than air or heavier than air. If it was heavier than air, then this bubble won't be able to go up. But the hydrogen gas is lighter than air, that's why it is going up. So here we are confirming that hydrogen gas is lighter than air. In second experiment, we have taken two different test tubes. In this we have filled the air, and in this we have taken the hydrogen gas. Now when we are mixing this test tube and we are just placing one test tube on another, and we have to take care that the below test tube has to be hydrogen gas test tube. Now when you are placing the air test tube, air filled test tube on the mouth of hydrogen gas for some time. After that, when you will take a glowing splinter near this mouth of, you can just separate them two. In that little gap, you can just push this glowing splinter inside, and you can see that the spark towards the test tube which is remained at the top. So what has happened is, when you have placed the air filled test tube on top of the hydrogen gas, being lighter, hydrogen gas is lighter than air, so air has come down and the hydrogen gas has gone up. So when you have taken a glowing splinter near or in between two test tube, then you can see spark at near the test tube which is remained at the top, because hydrogen gas is lighter than air and it has shifted towards the top. So this question can be asked in the exam, that prove that hydrogen gas is lighter than air. Sometimes they will give you a specific experiment that with the use of two test tube, one filled with hydrogen and one filled with air, how can you confirm that hydrogen gas is the lighter gas, is lighter than air? Then you have to write this experiment. So when we are talking about a chemical property of hydrogen, that means how the hydrogen is reacting with other reactant and which kind of product it will give. Chemical properties we are checking through performing chemical reaction. That's why it is termed as chemical properties. Now combustibility. That means when hydrogen will burn in air. That also means when hydrogen is reacting with oxygen. Burns quietly with pale blue flame. Now hydrogen air mixture explodes with popping sound. So hydrogen air mixture is quite an explosive. Then we will see some of the important chemical reaction, and we can also say that hydrogen gas is very important in terms of industrial use because it is giving very important products. First is when hydrogen is reacting with oxygen, it will give us water molecule. Second is hydrogen will react slowly with chlorine when a diffused sunlight will be there. But it will react explosively with chlorine when a direct sunlight will fall on it. So this reaction is catalyzed by sunlight. If it is diffused, then this reaction rate will be slow. But when direct sunlight will be there, then this reaction will be explosive. Then in third reaction, the hydrogen will form ammonia when it is reacting with nitrogen gas. So nitrogen will react with hydrogen and it will give us ammonia, a basic product. And condition for this reaction is temperature we have to maintain 450 to 500 degrees Celsius. Pressure we have to maintain 200 to 900 atmospheric pressure, and catalyst we are using is Fe. Then fourth reaction is when hydrogen will react with moist sulfur, then it will give us hydrogen sulfide gas. A foul smelling gas is known as hydrogen sulfide gas. So these are some of the important reaction which shows that hydrogen is giving us very important industrial product, and that's why hydrogen is one of the important gas. Hydrogen is also termed as one of the strong reducing reagent. Hydrogen reduces oxide of less active metals. So what all metals are less active? Zinc, iron, lead and copper are one of the less active metal compared to potassium, sodium and calcium. So when these metals oxides are there, then reducing them is quite a task. When hydrogen can do that, that means it is a strong reducing reagent. When zinc oxide will react with hydrogen, the zinc metal we will get and we will get water molecule. Then when iron oxide will be there, that will react with hydrogen, we will get iron metal and water molecule. When lead oxide will be there, when it is reacting with hydrogen, we will get a lead and water molecule. Here, when zinc oxide was there, it has become zinc. That means zinc has reduced because we are losing oxygen from zinc. So zinc has reduced here. One of the reduction reaction is that removing of oxygen. So when we are removing oxygen from all this metal, those metal are termed as reduced metal. So that's why the hydrogen is termed as reducing reagent. Similarly, when copper oxide will be there, it will react with hydrogen. It will give us a copper metal and a water molecule. So all these oxides of metal will reduce to a metal itself. That's why a hydrogen gas is termed as a reducing reagent. Here when we are discussing the uses of hydrogen, we will also understand and we will learn the particular quality of hydrogen or particular chemical or physical property of hydrogen, and because of that this use has been possible for hydrogen. So first, hydrogen's quality is it is lighter than air. So this quality we are using in making air balloons. So later when we discovered that hydrogen air mixture is explosive in nature, so we have discarded this use, but earlier we were using this in air balloons. So here we have used the quality of hydrogen gas is lighter than air. So that's why we can use it in air balloons. Second is oxyhydrogen flame. Earlier also we have discussed that oxyhydrogen flame is very explosive and it achieves high temperature as 2800 degrees Celsius. So this is used in welding and cutting metals. So in this, the reason can be asked like oxyhydrogen flame is used in cutting and welding metals. So you have to write that oxyhydrogen flame is achieving a temperature and is burning at 2800 degrees Celsius temperature. And this high temperature, because of this high temperature, we can use that in welding and cutting metals. Then next is hydrogenation of oil. When vegetable oil will react with hydrogen at 200 degrees centigrade temperature, it will convert into fats. So this will happen only presence of hydrogen. So this is also known as hydrogenation of oil. So this quality is used in making vanaspati ghee. What all vegetable oil will be there, on them the hydrogenation reaction will perform. That means we are adding hydrogen to it and it will converting into fats. So from oil to fat. So it is used in vanaspati ghee. Then in chemical manufacturing. Earlier in chemical reactions we have seen that there are so many chemicals which are important in laboratory and in industrial purpose. Hydrogen is the main basic ingredient for that. So urea, ammonia, hydrochloric acid and so many more fertilizer and explosives we can make with the help of hydrogen. So we can say that hydrogen is a very useful manufacturing reactant for all of this. First we will understand oxidation. Name itself says that oxy means addition of oxygen. There are two other methods by which the atom will get oxidized. Second is removal of hydrogen and third is loss of electron from outer shell. So we will understand this one by one. First, addition of oxygen. When in any atom oxygen is being added to that, then this atom is termed as it is getting oxidized. So when copper is reacting with oxygen, this oxygen is attached to copper now. So this copper is being oxidized in this reaction because oxygen is attaching to copper. So that's why here copper is getting oxidized. Oxygen atom is attaching with one of the atom and it is a forming molecule. That's why this reaction is termed as oxidation reaction. Addition of oxygen is termed as oxidation. And here copper is getting oxidized because it is attached, the oxygen is attached with copper. In second, removal of hydrogen. When we are removing hydrogen from any molecule, that is also termed as oxidation. Not necessary that whether we are adding oxygen or not. Only removing of hydrogen also termed as oxidation. So in this reaction, this is hydrogen sulfide gas. When it is reacting with chlorine, it will give us hydrochloric acid and sulfur. Now, if you will see this, sulfur is attached with hydrogen and now the sulfur is alone. So we are removing hydrogen from hydrogen sulfide molecule. So sulfur is being oxidized in this reaction and hydrogen removal is happening here. So that's why this reaction is oxidation reaction. Then third is loss of electrons from outer shell. When any electron from outer shell is being removed, then the positive ion will form, that cation will form. And if there's already a cation, then it will lose its electron and will form cation with one more positive charge. Earlier it was Fe plus 2. This is ferrous. After losing one more electron, it will become Fe plus 3. This is ferric. Ferrous has become ferric after losing one electron. So iron is getting oxidized in this reaction. So this is oxidation reaction. So there are three ways by which oxidation reaction can happen. By addition of oxygen, by removal of hydrogen, and third one is by removal of electron from outermost shell. So we are changing its valency and its valency will become one more plus. So this all are termed as oxidation reaction. Now we will learn what is reduction. So it is exactly opposite to oxidation. In oxidation we have learned that addition of oxygen, removal of hydrogen. So here removal of oxygen and addition of hydrogen is termed as reduction, and gaining of electron is termed as reduction. So we will see one by one the example. First is removal of oxygen. So copper oxide is there. When it is reacting with hydrogen, this oxygen is removed from copper. So it is termed as reduced. So copper is being reduced here. Why? Because oxygen is removed from that. On the other hand, the oxygen will attach to hydrogen. So hydrogen is getting oxidized here. We can also say that. But here we are focusing in all this reaction. One is getting reduced and other one is getting oxidized. This is only for your reference. Here we are learning about reduction. In next topic we will learn about reduction oxidation reaction together, that is termed as redox reaction. So here we will focus on only reduction. So here copper is being detached from oxygen. If oxygen is added to it, then it is oxidation. But here the oxygen is removed from copper. So copper is being reduced. Here which atom is being reduced? Then it is copper. Then addition of hydrogen. Here chlorine was earlier alone. Now the hydrogen has been added to chlorine. So chlorine is being reduced in this reaction. Then gain of electron. Here FeCl3 is there. That means the valency of Fe is plus 3 in this. Via crisscross method, Fe and Cl. Cl has one combining capacity, one valency, Cl minus, and Fe is plus 3. So via crisscross method it is FeCl3. That means Fe's valency here is plus 3. That is how we can check the valency of any atom in the molecule. Then this Fe plus 3 has become FeCl2. FeCl3 has become FeCl2. How? Fe is plus 2, Cl is minus 1. Via crisscross method we will get FeCl2. That means Fe here is plus 2. Earlier it was plus 3. Now it is plus 2. That means electron has been added to this. Then only one plus charge has been reduced. So that's why this is gaining of electron. If we are removing electron, then one plus charge will be added to that. This atom has gained electron, then plus charge will reduced. So when Fe plus 3 will gain one electron, it will become Fe plus 2. When Fe plus 2 will lose one electron, then it will become Fe plus 3. This point is important to understand. So this is termed as oxidation. When it is becoming plus one more, then it is oxidation. Here we are talking about this. So this is a reduction reaction. When the plus charge is reduced, then it is reduction reaction. So all these three reaction shows that these are reduction reaction. So here copper is getting reduced, here chlorine is getting reduced, and here iron is getting reduced. Now we will see the redox reaction in which reduction and oxidation both will happen simultaneously. So here in this reaction we can see that hydrogen has involved. So either it will be a removal of hydrogen or it will be an addition of hydrogen. So we will see that from where hydrogen is being added to which atom. So here chlorine is alone and then hydrogen is being added with chlorine. So this chlorine is being reduced in this reaction. So this is a reduction reaction because hydrogen is added to chlorine. So Cl2 has become HCl. Cl2 has become HCl. So this is a reduction reaction, and which atom is being reduced? Then it is Cl. We can write that it is being reduced, then it is Cl. Now we will see about H2S. This is H2S. After reaction it will become only S. So hydrogen sulfide will become only sulfur. So hydrogen has been removed from this. So removal of hydrogen is from H2S. So H2S has become sulfur. So this is oxidation reaction, and being oxidized, which one is being oxidized? Then sulfur, because hydrogen earlier was with sulfur and after that it is not. So sulfur is being oxidized in this reaction. So chlorine is getting reduced and sulfur is getting oxidized. So when one is getting reduced and other one is oxidized, both things will happen simultaneously in one reaction, then it is termed as oxidation-reduction reaction, or it is termed as redox reaction. Now there are some important oxidizing agent and reducing agent. For oxidizing agent, nitric acid, sulfuric acid, all are very strongly oxidizing agent. They will oxidize the molecule. So that's why it is termed as oxidizing agent. On other hand, some are the reducing reagent which will reduce the molecule. Hydrogen, carbon monoxide and sulfur dioxide are some of the example of reducing reagent. So this is all about oxidation reduction reaction. If you have any doubt, comment down below or you can write me at my email address. Don't forget to subscribe Learn Yourself for many more important videos. I'll see you in next video. Till then, keep learning, keep sharing.